Hi everyone, welcome to the Literacy Teaching Toolkit Science webinar. Lovely to have you all here tonight. Before I begin, I would like to acknowledge the traditional owners of the lands in which we come to this meeting. I would like to pay my respects to elders past, present and emerging, and thank you for taking care of this country for countless generations. My name is Narissa Leung. If you haven't joined me here at Basto for a webinar before, welcome. I am a literacy consultant here in Victoria. I'm a previous primary school principal and principal network chair, and I now facilitate a number of Basto's literacy courses in the literacy suite, including leading literacy, literacy data assessment practice, and some other work, and I do some other work in schools as well. My contact details are there on the slide. I am at RisAl on Twitter, and then I'm Auslit Teacher on all of the other pipes. I don't have an Edgemail account, so please don't email Narissa at Basto for the Edgemail account, because there is actually another Narissa that works here, and she doesn't need to be receiving all of my emails. So it's narissaleung@gmail.com if you're interested in emailing me. All right, if you are new, the structure for tonight's webinar is, fortunately for all of us, I am not going to speak for the whole entire hour and a half. That's good for both of us. So what happens is that I'm going to present you with some content, and then I will usually ask you to engage in some type of reflective activity. Now, I've shared a quote with you here. This comes from the book Academic Conversations, and I'm just going to read it out because I think it's a really important point. They say, since the dawn of language, conversations have been powerful teachers. They engage, motivate, and challenge. They help us build ideas, solve problems, and communicate our thoughts. They cause ideas to stick and grow in our minds. Conversations strengthen our comprehension of new ideas. So I'm sure you're wondering, why am I sharing a quote about conversations when we're in this online environment? In this online environment, obviously we can't have face-to-face conversations, but we do our best with the technology, and that is why we have a back channel for the night. So a back channel is basically just a chat that happens on another screen. So we use Padlet as the vehicle for this, and you will have received the link to the Padlet address prior to tonight's session. If you didn't get the link, that's okay. I've got it on the slide here. So I'm asking you to open up a tab on your screen and open Padlet, because that is where we are encouraging you to join in the conversation about the things that we're talking about tonight. This conversation works best when you share your aha moments, when you share your resources, when you share, oh yeah, that reminds me, here's a link to something similar. The great thing about this Padlet is that it's accessible after the webinar. So in a couple of weeks' time, when you've been sleeping on the thoughts about what you've learnt tonight, you can go back to the Padlet and say, oh, I wonder where that link is that person shared, that links to that resource. So keep this Padlet address and keep coming back to it. It can be a really useful resource. The other reason you need to download or open up the Padlet is because the Basto staff have put a link on there to the supporting resources pack for tonight. So we always ask you at different points during the session to stop and think and reflect, what does this mean for you and your practice? So there's a supporting resources pack that has some visual organizers in there to help you with your thinking. And there's also some activities in that pack that we're going to refer to later in the session. So I recommend you download the pack and either print it or just have it handy on your screen. So I'd love you to introduce yourselves in the chat. I can see a few of you have already done that. It's lovely to know that there are real people out there. So hello everyone that's introduced themselves in the chat already. So that's where our conversation is going to take place tonight, because we can't do the face-to-face stuff. All right, so tonight we're going to focus on a couple of different things. The first thing is that, these are our learning intentions for the session. Participants will understand the importance of explicit teaching of disciplinary literacy in the science classroom. And we're going to look at that. What does that mean? What does that idea of disciplinary literacy? Try saying that 5 times fast. What does that mean? Develop a knowledge of a range of effective disciplinary literacy teaching practices for the science classroom, And we're also going to deepen knowledge of the range of supporting resources, including obviously the Literacy Teaching Toolkit for Science, for assisting implementation of high quality teaching and learning practices. So they're the three things that I'm going to focus on tonight. The success criteria by the end of the session, my aim is for you to be able to do these things. Describe reasons why explicit teaching of disciplinary literacy is important in the science classroom. List a range of practical literacy-related activities. Reflect on your current literacy-related activities in terms of the science classroom, and then list a range of supporting resources. This is only a 90-minute session. There is absolutely no way I can impart everything you need to know about literacy and science in this 90-minute session. So I like to think of this as the launching pad or the tasting plate, whichever metaphor you like. It's just an introduction to what's out there to pick your interest, so that then you know where to go for further information and to engage in more self-education, I guess. So that's what we're talking about. So we're going to do that by firstly talking about the what and why of disciplinary literacy, then exploring the toolkit itself. I'm not going to spend a whole lot of time on this. Last year I presented on the Birth Level 10 Numeracy Guide for Maths, and I do find in this format it's a bit tricky for me to be clicking on every page on the website and saying now go here, now go here. So I'm going to give you an overview so you know what's available on the Literacy Teaching Toolkit for Science, and you'll have a bit of an idea about what's there and where can I go for more resources. Then we're going to dive into one area of disciplinary literacy, and that is vocabulary in the science classroom. We'll talk about why and how related to that. And finally, very, very light touch on reading practices in science. So we'll see how we go with that. So first, let's address the elephant in the room. So I am assuming that, I'm thinking that people are probably coming from one of three groups to this session tonight. You might be a literacy leader and you have been tasked with the job of building a culture of literacy across your school. What does that mean? And that means part of your role is that you've been asked to get all of the content area teachers to start teaching literacy. And you're coming to this session wondering, how can I support the content area teachers to explicitly teach literacy in their content area? That might be you. You might be a science teacher and you have students in your class struggling to engage with the content, and you have a feeling that it might be the literacy that is actually the issue for them. Or you might be a science teacher wondering, why do I need to teach literacy? Isn't that the English teacher's job? And that's perfectly fine. We're going to talk about exactly that tonight. So let's start off with addressing the elephant in the room. Why doesn't the English teacher teach all of the literacy the students need to know? Let's just put it out there. Let's ask the question. Okay, so let's look at this. This is a quote from Adolescent Literacy in the Academic Disciplines. Given the distinct ways different academic disciplines use language to make their own meanings, students need to develop differentiated literacy skills and strategies for interacting with the texts of each discipline. So this is the start. We're building our knowledge around, why do I need to teach literacy? I've already got enough content to be getting through. It is no longer appropriate to talk about literacy across the curriculum. Instead, there is need to delineate curriculum literacies, specifying the interface between a specific curriculum and its literacies, rather than imagining that there is a single literacy that could spread homogeneously across the curriculum. Interesting, because we have talked about this idea of literacy across the curriculum for quite a time now. So let's look at that. We've started to have a bit of a shift in the research and the practice across high schools around literacy. And we're moving from this idea of literacy across the curriculum to recognising that each content area, or each discipline, has its own literacy. So if we have a look over here on the left-hand side, this is that idea of general literacy. So what we probably in the past called whole school literacy or literacy across the curriculums. So we talked, and you may have been involved in this in the past, we've talked about comprehension strategies. So we thought we got all of the content area teachers to teach the same comprehension strategies. So we might have engaged in teaching our students about predicting. What does predicting look like in a science classroom compared to the maths classroom compared to the English classroom? Same for questioning, inferring, etc. In terms of general literacy, some schools may have been involved in that idea of writing to learn, so that low stakes writing. How can we get students writing in every single curriculum area? Vocab instruction, we've looked at that in different schools and approached that in different ways. Accountable talk, and sometimes even inquiry. When we're looking at disciplinary literacy, we're recognising that each discipline has its own literacy. So there are skills and knowledge sets that students need, literacy-related skills and knowledge, to engage in the content of that discipline. So the literacy in the content areas is focused on how experts in the discipline think, how they speak, how they read, and how they write. And we will unpack that a bit further. We're also looking and talking about language features and texts of the disciplines and how they're different, and the skills our students need to be able to unpack those different texts and language, the different language features. And this is the one that we're going to go into tonight, discipline-specific vocab instruction. So recognising that there's not one size fits all for vocab instruction, and what's the type of vocab specific to this discipline that our students really need to be have some explicit instruction in. All right, so disciplinary literacy refers to the learner's ability to read, write, and speak in ways that are valued and used by people in a given discipline. This comes from the Literacy Teaching Toolkit. That is, to think like mathematicians, read like historians, and write like scientists. So we've got to start to think to ourselves, or to start to ask, what does each discipline value and use in terms of literacy? If we want our students to write like scientists, what does that mean? What are the skills our students need to have to be able to write like a scientist, or to think like a scientist, or to read like a scientist? So disciplinary literacy, and this comes directly from the toolkit, recognises that literate strategies differ across the disciplines. So the strategies, the literacy-related strategies in science are different to the ones needed in maths, are different to the ones needed in English. It means that literate strategies and discipline-specific content are intertwined. So while I have this, I've got an enormous amount of science content I need to get through, the research is saying that the literate strategies actually are intertwined with that content. They're not separate to that content. So it's not an addition to all of the things that I'm already teaching as a science teacher. And the third dot point, that disciplinary literacy enables students to develop their content knowledge, their skills and understanding to become experts within a discipline. So again, reiterating that idea that if we invest time and effort in building the literacy skills of our students to think, read, and write like a scientist, the end product is that our own discipline is the winner. Our students are able to engage in the content more deeply if we build their skills to be able to think, read, and write like a scientist. So let's have a look at the first dot point in a bit more detail. So that idea of literate strategies differing across the disciplines, because I'm still wondering, why can't the English teacher be teaching this? All right, so let's take reading. What are the literacy related skills that a student needs to be able to engage in reading in an English class? Okay, so this comes from the book Disciplinary Literacy in Action, and it's got some really brilliant ideas in there. So in an English class, students, for their reading, they need to be able to find meaning through literary techniques. So we're talking about things like simile and metaphor. So we're trying to really deeply understand. We might be reading a narrative, and we're trying to really deeply understand the character motives. And we're looking for literary techniques that can help us to understand this narrative. We are looking at identifying themes. So throughout the narrative, what are the main themes that are coming up in this text? Recognising bias. Maybe it's not a narrative, maybe it's a persuasive argument, and being able to recognise whether the author has a bias, and how do we know that? What are the clues along the way to help us know that the author of this piece has a bias? Summarise, synthesise, analyse, and evaluate. And generally this is around deepening our understanding of the text or of the characters or of the plot if we're reading narrative. We need to be able to make connections. So the connections that we're making in an English class might be connections to other texts that we've read or viewed. They might be connections to the world around us or connections to our own lives. We need to pay attention to the craft of writing. And we're paying attention to the craft of writing because we might want to write in that same genre ourselves. So we're looking at a mentor text and we're saying, you know, how did this author construct, how did they make me feel tense? What did they do to build tension in this article or this text? Because I'm then going to apply that in my writing in the English classroom. And recognize elements of stories, poems, and novels. So we need to, you know, maybe that's part of recognizing how they're laid out, all of those types of things. So these are some of the skills that an English teacher will be focusing on when looking at reading. Let's flip over to science now and say, what are the skills that a student in a science class, reading related, what do they need to focus on? So firstly, they need to assume an objective stance. So we're going to assume when we're reading a text that it is objective, which could be very different to what happens in an English text. Students will be expected to ask why, how, more than what, okay, which is very different to an English text. Rely on data, sketches, charts, and illustrations. So there's a lot of visual literacy required for being successful at reading in the science classroom and in the field of science, as opposed to English, where we're probably not really, unless we're reading graphic novels, we're not relying so heavily on extracting data from the visuals, the graphics, the illustrations, the graphs, those types of things. We're making connections, but it's about known concepts to new concepts. So it's more about the content knowledge connections that we're making. So I used to think this about atoms, and now I'm reading this and I'm trying to work out how does that match with what I already knew about them or thought I knew about them. We are determining the validity of sources and the quality of the evidence. So when we're reading a report in science, we're constantly asking, how valid is this? Because we know that in science, people update the research. So if we're looking at a research and it's, you know, way back in 1950, then we're probably going to be asking questions about, is this still valid? Whereas in English, if we're reading a text, we could be reading a text from the 1700s and still see it as absolutely valid. Probably very hard to read nowadays, mind you. So think about something like Shakespeare, absolutely valid, and we would still read that without questioning, you know, is this valid? So in science, though, we're always questioning, is this valid? Who wrote this? Do I need to be coming to it with a bit of a questioning mind? We need to recognise the importance of precise scientific vocabulary. And we're going to talk about that vocabulary later. We're usually coming to the text with a search for answers. So we're usually reading some type of scientific text because we've got a question that we want to find the answer to, which isn't necessarily the same for English. In English, we might be reading purely for the joy of reading. We might be reading to find out how does a character handle something in the text or handle a difficult life event. Very different to science, which impacts the way that we read. It means that we might skim. We might look for, we might skip the first 6 chapters and head straight to chapter 7 of a textbook. But if we did that in English, it would completely change our understanding of the story. And we're looking for details and evidence, usually because we have a question, so we're trying to get to the details and the evidence very quickly. So you can see really different skill sets and really different approaches to reading, and that's just for English and science. So then we'd have a different table for maths and the skills required in humanities. All right, so let's think about writing. So in writing in the English classroom, we are encouraging our students to use a process. So we're going to teach them about drafting and about revising and about editing. So all of those types of things. We are going to teach them about flexibly using organisation, details, elaborations, and voice. So we don't write to a structure. We understand there are general sort of guidelines, but we also understand that usually when we break the guidelines, that's when our texts are more engaging. So when we do change up the organisation, or when we do play with voice in our writing in English, that's when we engage the reader. We avoid formulaic writing in English because our purpose is to engage the reader or entertain them or to inform them. We want them to keep reading. So if we have it, if it's very formulaic, it's very boring and we're not going to keep reading. So we try and avoid that in English. We employ literary devices and techniques. So the ones that we learnt when we were reading, you know, maybe simile, metaphor, all of those types of things, alliteration, we're now going to flip those over and we're going to try and employ those in our writing because that author engaged me, and so now I'm going to give that a go myself. We'll use credible evidence and we learn about which evidence is credible. Use mentor text. So a mentor text is we'll just craft off a published author, it doesn't need to be published actually, another author's text. So say for example, on my Auslit teacher social media, I put picture storybooks on there and I say how you might use the picture storybooks to teach certain elements of reading or writing. So that's a mentor text. We're looking at how an author has used voice to engage the reader, really looking at the craft moves they've made and then trying to do that in our own writing. We will adapt our communication for various audiences. So when we're writing in English, we think about who is our audience. So maybe if we're writing for kindergarten students, then we're going to change the language that we use in that piece of text. Whereas if we're writing for our parents or the school community, or we're writing a letter of support, or we're writing a persuasive text for a counsellor, then we will always be cognizant of who is our audience, and we're going to change how we write it based with that audience in mind. And we apply effective techniques for argumentation. Okay, let's look at science to think about what are the techniques and skills and the knowledges that students need about writing in the science classroom. All right, firstly, we need to use precise wording. So over in English, we can play with the wording a bit. We can be a little bit creative. We can even invent words in English. So if you think about Roald Dahl, you know, BFG talks about snozcumbers and scrumdiddlyumptious. Half of Shakespeare's words are invented. Don't quote me on the half, it's probably less than half. But there's invention of words is absolutely fine. We cannot do that in a science text. It's about precise language. We compose in phrases, bullets, graphs, sketches. We try and communicate a lot of information in a really concise manner. We favour the passive voice, very different to English, where we're really trying to create an engaging voice. So over here in science, we're talking about the passive voice. What does that even mean? How do I create passive voice? Because I'm so used to writing in English. How do I do that for science? We seek exactness over craft. So it's not so much about having all the frilly engagement in writing. Not that engagement's frilly, but so it's more about I have a really clear message that I need to communicate, and that's the main purpose of the text that I'm creating. We communicate in a systematic format. So generally if we're writing, say, a prac report, there's a format for that. And if we start messing with that format, it's really going to impact the reader's ability to understand what it is that I'm trying to communicate. So where in English, we're sort of avoiding formulaic writing. Over in science, to a point, we're almost promoting it. So we need to learn about what are the formats that are acceptable in science. And we can look at that by looking at mentors. So looking at published articles or articles that other people have written or texts that people have written in science. We distinguish fact from opinion, whereas over in the English world, we might spend a lot of our time in opinion. So over here, we're talking about facts and how do we know that they're facts. We generate lots of questions. Science, it's all about questions and being curious, and provide details, narratives, and causal effects. So there's a lot of difference between the English required or the literacy required in an English classroom as opposed to a science classroom. This is what we're talking about when we're talking about disciplinary literacy. So a few implications for this. If we are a literacy leader trying to get literacy happening in all of the areas, then we need to think about what are the literacies of that content area. And we might not necessarily be the experts in that. The content area teachers are the experts in how they read, write, and think in their content area. Okay, I'm going to play a little video from the toolkit that will help broaden our understanding of the other types of literacies that are required in a science classroom. And I also just want to play it because it shows you the quality of the videos that are available on the Literacy Teaching Toolkit. So while you're watching this, I want you to be thinking, what else am I learning about the differences or the importance of the literacy in science? Let's have a look at it.
It's important to pay attention to literacy in a science classroom for a number of reasons. Firstly, these days we teach science through a range of means, and we expect students to communicate that in a range of means as well. We also know quite clearly that in focusing on some of these literacy techniques, that students' understanding of science will improve.
Nowadays, of course, it's not always in control of the teacher what the students read. They read a variety of text, and with that comes a potential confusion, because those texts will use the same jargon in different ways. And an important job for the teachers then becomes to sometimes unpack one of those texts or compare a couple of texts and help them to make sense of the meaning, and also connect those different texts and say, well, they use a different term here, but it's actually the same thing that is used over there. That becomes a more prominent aspect of teaching in science these days.
I think there is a move away from only doing writing in prac reports and increasingly doing more argumentative pieces. Yep. So, putting forward an issue to a class and getting students to write about an issue or present more recent research on a topic. So students would be going away and researching that and then writing a piece which would be more in lines with an argumentative piece, where they're having to not only present the science behind something, so for example renewables or something like that, but it could also be putting forward a case for why they should or shouldn't be introduced, which is a different thing to just reporting what you see. It requires a different kind of writing. It's
also important to know that science texts contain a lot of visual information. There's always lots of diagrams, graphs, models, formulas, symbols. And that is very essential, of course, in the learning of science, is the understanding of what that all means and how you make sense of that. It's learning to connect language with visual information, and visual information that can be presented in different modes of representation, so to speak.
And something possibly we underestimate is difficult for students to be able to do is to make those links between the ways that we represent them, these ideas visually, and how it might be explained in attached text. And related to that, also, we do tend to use a lot of analogies and models, because a lot of the ideas we are dealing with are very abstract and difficult for students to see. And so we use these kind of analogies and models as a way of trying to help students in understanding those. But in the process, sometimes we also lose students. So it's about also bringing them along for that ride as well.
Okay, there is so much to consider when it comes to literacy in science, and I think that's just the tip of the iceberg there. What we do need to consider is the gradual release of responsibility. So if we want our students to have the skills to engage in all of these activities and to really extract meaning from the text we're providing them in our science classrooms, then we have to take them through this gradual release of responsibility to build their understanding about how to extract that information or how to create these texts for themselves in the science classroom. So I always like to take the opportunity to put the gradual release of responsibility up there to get us thinking about what are the supports that we've put in place. So when we ask our students to write a prac report, have we built their capacity to write an effective prac report? Have we talked about what goes into an effective prac report? Have we looked at other models of a prac report before we ask our students to write one themselves? Do we know what are the elements? Do we know what makes a good one, what makes a poor one, those types of things? So you can see here, and I'm hoping this isn't new for you, that idea of the I do it, which is the teacher modelling and showing the best way to, so maybe let's talk about reading. So how you as a scientist engage with the text. So you might model that, do a think aloud. The students would have a go at practicing that themselves before we expect them to go to independent practice. So too often we skip straight down to independent practice and expect our students to have the skills that they need to engage with these texts or to create these texts in our content area classrooms. So if you want more information on the graduate release of responsibility, I recommend Fisher and Fry's book, Better Learning Through Structured Teaching, and they go through each of those phases in more detail and help you to unpack what does it look like in a classroom. Okay, there's our first chunk of information. I'm going to give you 2 minutes. So in the supporting resources, activity 2 is a reflection. And I know 2 minutes isn't a lot of time, but I just want to pause so you can start to think about the first section there is what did you agree with in all of what we've been talking about disciplinary literacy? What does it mean? What does literacy in science mean? The second one is what is the most important thing that you learned? And then the third is what questions do you still have? So I'm going to provide you with 2 minutes just to stop and jot and think about, reflect on all of what we've just talked about. And if you're fortunate enough to be in a room of people, you can do a turn and talk face to face. And I would love you to share some of your thinking in the back channel there. So some of your, what did you agree with? What did you learn? And what questions do you still have? And I'll be back here in 2 minutes. Timer's on. I hope they all print off the resource. There's a reading to do later. Yeah. Anyway. Okay, I understand 2 minutes is very quick. In fact, you can cook a whole bunch of noodles in 2 minutes. That was my whole uni diet. So just a short time to reflect on some of the thinking there. And thank you to those people who have been putting their thoughts in the chat. It's always helpful to see what's helpful and any questions that you still have. All right. We're going to do a whirlwind tour of the Exploring the Literacy Teaching Toolkit Science. Now, as I said before, I'm not going to go through and say, click this page now, click this page now, click this page. I'm just going to give you an overview so you know what's available. I would love you to tell us in the chat, have you already had a look at the Literacy Teaching Toolkit Science? Is this the first time you're looking at it? Let us know. I've got some little helpers in the chat that can answer any questions that you might have about it. Let's put them to work. Okay, so on the Literacy Teaching Toolkit, the science, this is what you'll see on the main page, and you'll know we're on the main page because I've put a big red border around it on my screen, not on the actual toolkit. Okay, so there are 4 subpages that spring off this main page, and I'm going to talk about each of those little subpages. So the first one, Introduction to Literacy in Science. So let's zoom in and have a look what we get on that page. On there, the first section is focused on literacy in science, and it talks about science literacy and literacy in science and the difference between those two things, and sort of goes into that idea of disciplinary literacy. Also, it talks about the Victorian curriculum, the literacy in the science part of the Victorian curriculum, And at the bottom of every page, it always puts a list of references. And the references are really valuable. So if you always click on the expand the references to see, and you can go off and, spend the rest of your holidays reading all of the other things, if you're anything like me. So let's go down to literacy in the Victorian curriculum science to see, well, what does the Victorian curriculum say about literacy in the science classroom? So here, way too much text on a slide, but I have put some in bold, so I think it's not that bad. The science inquiry skills strand emphasises the subject-specific nature of language and literacy requirements as part of the scientific method. Within science, students do reading and writing, viewing, speaking and listening to identify and construct questions, propose predictions, plan experiments, record and analyse data, and communicate information and ideas. That's not new to us, hopefully. The literacy demands of science go beyond the inquiry skills. And this is the part that I've bolded here. Being able to read, view, write, speak about, and listen to a variety of texts in science allows students to access new scientific content and, as a result, develop their scientific knowledge. So again, we're saying, or reminding science teachers that investing time in the literacies in science is helping you to get the content knowledge across. So it's not a separate, I've got to teach all this science and now I have to teach all this literacy as well. It's intertwined. And by building the students' skills to access the text and to create texts in science, we're building their ability to develop their scientific knowledge. Okay, let's go back to the main page. So that was the first page that's available. So you can go and look at different things related to literacy in science and science literacy. Say that 5 times fast. All right, on to the second one. So the second page is developing understanding in science. So what happens on this page, you have access to 3 other pages. And I always try and work things out in my head, an easy way to remember what's going on here. So the first one, you can see introducing scientific language. So really we're talking about the vocab of science on the first page. And I will say here that all of the resources on the Literacy Teaching Toolkit Science, there's a really good mix between theory and the research and practical activities. So it's so supportive. You can come on here and really build your own knowledge around how do I teach the vocabulary of science and see what the research says, and then look at some practical activities. And they usually have links in the resource section to further learning. On the second page, we're looking at reading and summarising written language in science. So we're really talking about reading in science and looking at text structure, using graphic organisers. They introduce the Cornell note-taking system and give you some practical ideas for how to engage in those tasks. And then the third page, reading and explaining visual scientific images. And we heard in that video before just how critical the visual literacy is in science. So this third page here is all about the visual literacy. So it's focusing on explicitly teaching students how to read scientific images and diagrams. And that's something that some of us take for granted and some of our students take for granted too. So again, a mix of theory and practical activities for how do we build our students' capacity to engage that visual literacy. Okay, back to the home page. I hope you're with me here. You can see how this is getting a bit confusing, sorry. On to the third page, communicating understanding in science. So what happens in this page? We get 3 more sub-pages, okay? So the first one, drawing scientific visual representation. So on that other one, we're really looking at interpreting the visual literacy, and now we're looking at creating it ourselves. So critiquing and creating, actually. Okay, so that's really about visual literacy again, but it's more about being in creation mode for that visual literacy. The second one, reading and writing scientific recounts and explanation, we're talking about writing. And again, it helps you to break down because we don't always expect all of the science teachers to be totally over what are all of the exact text features and structures of a scientific text. So on here, there are some great examples of a scientific text that's been pulled apart to help you to work out how best to teach this to students. And the third one, developing scientific arguments and discussions. Again, it's focusing on writing and providing you with practical ideas about how to build student capacity in this area. Okay, back to the main page. And this time we're going to look at the fourth and final set of subpages. And this is science putting it together. Little bow on the top. What does it look like? So we've got writing the practical report, learning sequence and references. And this really focuses on practical report writing. So it sort of goes in depth with how to help students to build a prac report. What does a good prac report look like? What are the features and how do we build the capacity of our students to create one of those? And it also provides some example learning sequences. So it sends you, gives you a link to some learning sequences on Fuse, and it can helps you to run lessons on how to write an effective prac report. So basically, it gives you an overall kind of picture about how some of this disciplinary literacy sort of all ties together in a science classroom. So that's why it's called Putting It Together, I suggest. So there you have it. That's the overview. Obviously the best way to learn about what's on there is to click every single button and have a look for yourself. So sort of just to recap, the first one, Introduction to Literacy in Science, is really about sort of what is literacy in science and a bit of that disciplinary literacy stuff. The second one I think of as more sort of the receptive modes in science. So the reading and the interpreting, so what's coming into the mind through texts. The third one, communicating understanding, I think of those, that's really the expressive part of it. So what are the students generating? What are they sending out? And how do we build their capacity to do that? And then tie it all together with a little example at the end there. So that is the toolkit in a nutshell. But I obviously recommend in your own time, not right now, I know you're all going to go and click on it, probably already have, just go and look at all of the pages and see what the resources are that are on there. There's some really great and very supportive stuff on there. Okay, we are going to turn our attention towards vocabulary. Vocabulary instruction in a science classroom. Now, the reason that I've selected vocabulary out of everything that we could work on is because I think science is a really fertile ground for explicit vocabulary instruction. So we are going to look at the why and then the how of vocabulary instruction in the science classroom. Let's look at it. Firstly, we're going to look at what some of the literature says about vocab instruction. So, the vocabulary in science textbooks is dense. No kidding. The amount of technical vocabulary is greater in science textbooks than in textbooks in any other field. Wow. Okay, so that's a really big point about why do we need to be spending our precious minutes in the in the science classroom explicitly teaching vocabulary. So the technical vocab is greater in science textbooks than in textbooks in any other field. Even more tricky if our students are already coming to us with reading challenges. And now we're going to throw some technical vocab, scientific vocab, on top of those challenges. Okay, vocabulary knowledge is content knowledge. And I use this quote because I really want to highlight this isn't I teach all of my science and then I go off and teach this vocabulary, and they're two different things. They're one and the same. Vocabulary knowledge is content knowledge. Research reveals that vocabulary knowledge is the single best indicator of students' reading ability, comprehension, and familiarity with academic discourse. And aren't they the things that we want in our science classroom? Don't we want our students to understand, to comprehend what they're reading and be familiar with the language of science? Because of this, vocabulary knowledge is one of the best predictors of student success in school. Wow. We need to spend some time explicitly teaching the vocabulary of science. Okay. As we saw in one of those quotes, science textbooks are dense. Didn't need me to tell you that. You've been reading them for a while. Now, scientific language can be rich with abstraction, and we heard that in the video before. Lots of abstract terminology, and very dense, which I absolutely don't need to confirm your thinking around that. I want to share with you, let's look at these two statements, that it's rich with abstraction and very dense. I'm going to share with you the first paragraph from this resource. This is a resource from, it's linked from the Literacy Teaching Toolkit, The Science of Climate Change, Questions and Answers. It's from the Australian Academy of Science. Okay, so I'm just going to share with you the first paragraph of this text. Weather is the state of the atmosphere, its temperature, humidity, wind, rainfall, and so on over hours to weeks. It is influenced by the oceans, land surfaces, and ice sheets, which together with the atmosphere form what is called the climate system. Okay, let's think about that first provocation, that scientific language can be rich with abstraction. Where can we see evidence of that? In this very first paragraph of this text. So if you think about this text, this paragraph, this entire paragraph is explaining the first word of the paragraph. The whole paragraph is about that first word, weather. Okay? So when our students read that word weather, they've got to keep that concept in their mind for the whole rest of the paragraph. There's a lot to keep in mind. If you think about this idea of the state of the atmosphere, I'm still trying to get my head around what that means. It's temperature, humidity, wind, rainfall, and so on over hours to weeks. What over hours to weeks? What does that relate to? What does that mean? So I've got to keep that first bit of information in my head and now understand where that hours to weeks relates to weather. Okay? So it is incredibly abstract for some of our students to read. Dense, is it dense? Do you think, have a look at what's the evidence in this that it's dense? Yes. Students have to hold lots of information in their minds just to make sense of the sentences that are in this paragraph. So we begin with a really complex state. They've got to hold this in their mind, and we get down to finer and finer details as we go along. This whole paragraph is just about one small concept. We haven't even got to the idea of climate change yet. Okay, so it is laden with dense and complex terminology. Now, thinking about that idea of complex terminology, just to add an extra layer of this to really show how sort of complex this paragraph is in this text, is that I've highlighted the words here that involve polysemy. So polysemy, poly mean many, words that have lots of different meanings or more than one meaning. So if you look at the words in red, state, what does state mean? So we live in a state, Victoria, okay? Land, so when I land a jump, so when I've jumped and I've landed on the land. Surfaces, so I may have been underwater and then I've surfaced as opposed to the land surface that we're talking about here. Ice, a few different meanings for that one. We've got the drug, we've got the stuff that we put in our freezer. Sheets, we've got the ones that go on our bed. We've got the ones that are sheets of paper. We've got now we have sheets of ice. So there's a huge potential for confusion in these texts. So dense, so much information just in that one paragraph. If you want to add on top of that, if we have emergent bilingual students in our classroom, even more confusing potentially. The words in yellow, I've just highlighted those because I thought these are words that some of our students may have come across in other settings that could also confuse their understanding. So if you think about influenced, we talk about being under the influence. So is that a different, when we're talking about that, we're saying drugs or alcohol. So how is that related to this? Or atmosphere, sometimes students may have heard about atmosphere in a different situation. So maybe, you could cut the atmosphere with a knife, is that the saying? Or, the atmosphere in here is very tense. Is that a different atmosphere? Or how does that link to this paragraph here? So I'm hoping that I've convinced you that yes, scientific language can be rich with abstraction and very dense. So this is why we need to take our students through that gradual release of responsibility to help them to access the language. Okay, Why can't scientists just use words people actually understand? Good question. Glad you asked. I'm sure this is a question that you have had yourself, and this goes back to that idea of our students need to understand why scientists do use precise language. So it is important for scientists to use accurate, concise, and technical language to convey important and abstract ideas. Okay, I'm going to share with you a little, I'm not going to say it's a story, it's not a story. It's a little excerpt from this book called Words Their Way, Vocabulary for Middle and Secondary Students. And this book is all about teaching explicit vocabulary for the different content areas. So if you're an English coordinator, or if you're a literacy leader in your school and you're tasked with building the capacity of different content areas to improve their teaching of literacy, this book might be really useful for you because it goes into each of the content areas. I will flash up a picture of this at the end, and you will get a copy of the slides after this, so you don't have to worry about not being able to write the name down now. So in here they have a section called Thinking Like a Scientist, and this is one of the suggestions that they've talked about in terms of when this question comes up in the science classroom, why don't scientists just use easy language? You know, this is so confusing. This is one of the ways that they've dealt with answering that question. Okay, get comfortable. Think about the disease cancer for a minute. Many of us know how challenging and scary it can be to face cancer because most of us know someone who has struggled with it. Now, think about all of those scientists who are working to better understand cancer, to understand what it does to our cells, how it mutates and grows, and how to treat it. We need those scientists to really understand the research that has already helped some people with cancer. Then those scientists can continue working to fight cancer without reinventing the wheel or wasting time doing something that has already been done. We want those scientists to talk to each other and write to each other in research journals, using the most accurate and technical language possible. Then each new scientist can pick up where another left off, working together as efficiently as possible to treat cancer. Scientists in every field need to use accurate and precise language. That makes it seem tricky for us, and we often wonder why can't they just say that in simpler terms? But those simpler terms might not be telling the whole story. It's the technical language that really lets scientists explain exactly what happened in an experiment. And that's how we keep making important scientific discoveries. Great explanation. I don't think I could come up with a better one. That's why I've used theirs. So just an explanation of why that scientific language that trips so many of our students up is so important. And if our students have that understanding about the why, they'll be more invested in engaging in it when they're creating their own texts in science and not getting frustrated when they're reading or consuming texts in science. As science teachers, we need to help students both access the language of science and understand the very important functions that science language serves. Okay, so research has revealed we do not learn words one at a time. So let's talk about how do we teach the vocabulary of science. So the first bit of research is we don't learn words one at a time. Okay. Rich oral language plays a critical role. What might be the implications of that then, of those two things joined together? Students need, on average, 12 to 15 exposures of new words. Fascinating. This makes me think about, in my own teaching, how many times were my students exposed to words? Or did I do, an explicit lesson on Monday? We looked at the words a couple of times and then I assumed that they would have the knowledge of them for the rest of the unit. This is my husband who's trying to explain new words to me. He says it to me once and then says, I've already told you what that one means. So now I've got the research to back it up. I need it another 11 times. Thank you. New words. I think this one is a really critical takeaway. New words must be read, heard, spoken, and written. What are the implications for the science classroom teaching technical vocabulary? If this is what the research is saying around vocabulary, effective vocabulary instruction. Okay, so I'd love to know what your thoughts are. Put them in the chat. What are your thoughts around this research and what it means? What are the implications? And we're going to have a look at how do we take this information and turn it into practical application in the classroom. This is where I said before, science is a fertile ground for vocabulary instruction. Why? Because so many words in science lend themselves to morphology instruction. So that's what we're going to focus on. All right. Oh, first I forgot to show you, this is from the Literacy Teaching Toolkit, and this is on the vocabulary instruction page, and I'll read it out to you. It says, Leno and Doherty argue that methods of teaching vocabulary that focus on students copying definitions from a textbook is problematic for these 3 reasons. This is on our toolkit. 1, definitions in isolation can be too broad or too narrow, having no direct link to the topic being taught. 2, students may copy definitions absent-mindedly. Wow, really? They've been doing that since they were in prep, rather than reading and understanding the definition. So I've just copied it straight from the board or straight from the book, and we haven't actually processed it. Has anyone got this kid in their class? Number 3, identifying definitions within a passage of text may lead to incomplete or incorrect definitions. And we looked at that before with the polysemy and how confusing that can be. So that we can't rely on the age-old technique of copy the definitions from the textbook, put them in your book, and great, now we all know that vocabulary. We've got to take into consideration that research around effective instruction that says that we need 12 to 15 exposures. We need to read, hear, speak, and write the words. We've got to roll those words around on our own tongues. We've got to trial them, play with them. Over 90% of discipline-specific words contain Latin or Greek affixes and or roots. This is why I want to talk about vocab in science. Knowledge of just one root can be key to unlocking the meanings of many words, both discipline-specific and general academic. So we go back, over 90% of discipline-specific words contain Latin or Greek roots or affixes. So if we can unlock, and before, perfect example, I talked about polysemy. So you may never have heard of polysemy before, but you've probably heard of poly, and you would have thought, oh, poly, yeah, I know that. That means, a few, many, think of some other words, polystyrene, polyamorous, polyana. Come on, guys, help me out here. So you would have thought immediately, I'm not quite sure of what that whole word means, but I've got a bit of a leg up into the word because I know part of it. I know what the base is, poly. I know what it means. Okay, so in the Literacy Teaching Toolkit, in terms of vocabulary, there are 4 strategies that teachers can use to introduce new vocab to students. So the first one is teach base words and word parts or morphemes. Then they go into joint construction of definitions, naming processes, nominalization, which needs a whole other workshop on, and everyday versus scientific words. We are going to look at the first one of these, teaching base words and word parts, because we know back there that the research said there is a whole lot of our scientific words that have these word parts in them that can help our students build their understanding if they have access to them. Okay, so in your supporting resources pack, the one with the link was put onto Padlet. If you haven't got it, just jump back onto the Padlet and download it. On activity 3, I'm going to show you a list of words, and we're going to call it the meta language of vocabulary. So the vocabulary that we use to explain vocabulary. Does that clear it up? No, because we've got to talk about it 11 more times. Okay, so what I want you to do is in the first column, I want you to write the word down. I'm going to show you the words in a minute. And then I want you to think about, what do you currently know about this word? About the definition of the word maybe? So write what you know in the second column there. So I'm going to provide you with, I think 7 words. And I want you just to think about, what do I know about these words? And what definition do I currently have? Or if you don't know what the definition is of the word, maybe you could have a go and have a guess at what you think it might be related to. And then I will reveal the answers. Everyone always we're all teachers. We all like to, tick things off. Okay, so here are the words. So in the first column, just write down the name, write the actual word. And in the second column, write what you know about this word, what your working definition is. So I'm going to give you 2 minutes to have a go for each of those words. This is the meta language of vocabulary. They're very quiet in the chat. Is there anyone in that?
They respond when I put things up like that. There's 42 watching right now.
Oh, okay, that's good.
So new people came in a little while ago and added to the bottom a few of the previous posts.
Oh, do they? I'm worried that I haven't printed off the resource pack because there's a reading on there, so I really need them to read it.
One of them wrote they didn't even go to Toolkit system until turning on today.
Okay, how did you go? Now, I'm not necessarily suggesting that you should know all of these, otherwise you're not an effective science teacher. Well, this could be the first time you've been introduced to this meta language, and that's totally fine. This is absolutely an activity that you can do with your students when first introducing new vocabulary. Let me put you out of your misery. I'm going to give you the response. I'm going to give you a technical definition, I guess, of each of these words. So the first one, and this is probably easy because it was on the previous slide and I sort of explained it, a morpheme. So the definition is the smallest unit of meaning in language. They can be base words or affixes. An example is in the word birds, there are two morphemes. There's bird, which is a word by itself and is a unit of meaning by itself. And there is the S, which is also a unit of meaning. When I say S is a unit of meaning, in this word, it's a unit of meaning because it tells me that there's more than one of the bird. So it means that there's a plural. So it's a morpheme in this sense. Okay, so a morpheme is the smallest unit of meaning in a language. So poly, when we're talking about polysemy, poly is a morpheme. Morphology, well, first of all, what do we know about ology? You guys, you're in the science world. So I'm expecting you had half of this one close. It's the study of morphemes in words. Okay, so this is when we're looking into these scientific words to crack them open. Affix is the meaningful part we add on to the base words to make new words. So an affix can go at the start or the end of a word. So let's look at chlorine has chlor and ine. So one of those is the affix, the word that's either the prefix or the suffix that we've added on. Prefix, what do we know about the word pre? It's a morpheme. It means before. So this is the part that gets added, or the morpheme that gets added onto the front of the affix, onto the front of the base word. So an example is endo, is a prefix, and endo means within. So we have words like endothermal, endometriosis, give me another one, endorphins, maybe? Okay. The suffix is a word part that's added to the end of a base word. So ology is an example of a suffix and generally means the science of or the study of. The base word is generally a free morpheme, so that means that it's a word that can stand up by itself. So bird is a free morpheme. It doesn't need any other additions to it to make sense. So that's a base word. In earthquake, there are two bases, earth and quake. And those two bases have been joined together to form a compound word. And a root is a bound morpheme, so it's a unit of meaning, but it has to be attached to another, to something else, otherwise it doesn't make sense by itself. Okay, so a bound morpheme that cannot stand by itself. So therm by itself doesn't make a lot of sense. It means heat, but it has to be attached to something else. So thermal, thermometer, but we know if we see therm in a word, then it has something to do with heat. Okay. Why do I need to know all of this? Because when we're talking to our students about the vocabulary in science, we need to be talking to them about the prefixes and the suffixes and the base words and the roots to help us to crack open the meaning of some of these words that we're dealing with in science. If I were in the classroom now, or actually not now, after we'd engaged in more talk around these words, maybe the end of the week or the end of the lesson, I'll get students to go back to their original definitions and give them time to reflect to see if their definition included what was the overlap between what they'd originally recorded through their own prior knowledge, and now that we've done some work with those words and we've played with them, we've talked about them, we've rolled them around on our tongue, what's your new definition, your new working definition? Okay. We are going to talk about generative morphology. So we know that now that we've got that information, that I guess, the meta language of vocabulary, generative morphology. What does the word generate mean to us? Well, it means that if we know this, then we can generate other words that have a close meaning to it, essentially. Becoming aware of and understanding how prefixes and suffixes combine with roots will support a student's ability to generate knowledge about thousands of words encountered in his or her instructional and independent reading, particularly relevant for science. You need to teach these generative morphological processes as they apply to the vocabulary of your discipline, because most students do not discover, much less apply them on their own. So we, as scientists ourselves, need to be explicit about how we unlock the meaning of these words. Of course, we don't understand every single word we come across in a scientific text, but we need to help students to see what goes on in our mind to help us to have access to these words. Okay, I'm going to show you this video, another brilliant video from the Literacy Teaching Toolkit Science. And this is looking at a vocabulary lesson in a secondary science classroom. So when you're watching this video, I want you to think, what do you notice, like, and wonder? And I'd like to see your thinking in the chat. What do you notice, like, and wonder? And be thinking about that, what we've talked about vocab so far. Let's have a look.
We are about to deconstruct some scientific names based on morphemes, which is the smallest part of a word that has meaning, okay? And I'm going to show you how to read this table so that you can use it. So the challenge for teachers, whenever you're doing any science lesson, is to not make the introduction of the new words so overwhelming that the kids just come out going, I can't remember anything. That's number one. But also to be able to come back to it on a regular basis so that you can reinforce that and give them opportunities to learn it and use it properly and to make it fun. Who's ever heard of tonsillitis? Okay. Okay, so we've got the word tonsil. We've got the word itis. So it's part of a word, isn't it? It's part of a word. We're going to talk a little bit later on about parts of words. So the strategy that I'm using today is to be able to use the parts card strategy so that the students can very specifically unpack the morphemes that make up the scientific names. So in order to become more familiar with the unfamiliarity of both the words and the sounds of them, because we've got multisyllabic words that are completely unfamiliar to the students. So we're very specifically unpacking those morphemes using the table that they've got as a resource. Fascol is different from fascolo because we've added an O here to make a bridging sound so that we can add on arctos after it. What does osteo mean? Bone. What happens if something is porous? Is it solid or is it becoming more spongy? Becoming more spongy. What we're doing right now is we're putting all of the structures that we know the names of and assigning them a function based on our discussions so far, and also the properties of each of the different parts of the joint. And we're going to move from there onto finding the Latin prefixes for all of our parts. We want to be able to find out what the Latin prefixes are so that we can then unpack all of that language using the morphological matrix. We can now work out what this means. Osteoporosis is a condition that affects bone. So the osis means it's a condition. The osteo means it's got to do with our bones. And the problem is they're becoming more porous.
Okay, I really love that video because it really encapsulates all the things we've been talking about with vocabulary instruction in the science classroom. On the Literacy Teaching Toolkit, there are some practical applications to how can we engage students in tasks to assist them to understand the vocabulary of science. This is one of them, the part card strategy. If you have ever engaged in leading literacy or in other literacy courses, you might be familiar with the Freya model or the Freya chart. This is a modified version of that. So essentially students write a 4-part card. Top left, they write their word. Top right, they write the parts of the word, because again, we're getting them to look inside words and crack them apart to see, do I understand the meanings of any of the morphemes in that word? And the meanings. And then the definition goes down the bottom left. And the suggestion is that the students write their own definition and then they have the textbook definition, because sometimes, let's face it, the textbook definition needs a dictionary itself. So the students write in a way that they can understand it and something that means something to them. And then, if possible, they will draw a picture over there. And part of that idea of drawing a picture is because, as they discussed in the video at the start, a lot of the information that we deal with in science moves from text to visual and back to text. So they've got to be able to swap between those different mediums. So if possible, the students can draw a picture there. So that's just one strategy. So I can see some of you are putting in what you noticed, liked, and wonder about the video. Thank you for that. Those videos all available, or both available, on the Literacy Teaching Toolkit Science. So I absolutely would be using that one with your staff. Now, I'm going to test you. You thought you were being tested before when I gave you those 6 words, the meta language of vocabulary. Well, this is the real test. And some of you, I'm sure, have already been trying to nut this one out. I'm going to give you, in your resource pack, I've actually put if I say test, everyone will get anxious, won't they? And they'll think there's a prize. I've put a little, it's a test. I'm going to call it what it is. All of a bunch of roots and affixes that are used in the world of science down the left-hand side. I want you to have a go at seeing how many of those you know the meaning for and any examples. So I've filled the first one in amphi, meaning both, and then I've put amphibian and amphitheatre. So the reason I've put this in here, and I'm providing you only 3 minutes to do it, is because I want you to really understand how that idea of if we understand morphemes, we can unlock meaning to more than one word in the world of science. So I'm going to give you 3 minutes to have a go, and then let us know in the chat how you go with this. This is in the resource pack, so if you need to download it, head to the Padlet and download it. All right, 3 minutes, and then we'll come back. to include the document with all the answers on it, so I'll put it on the tab when I go home. They're going to hate that. If I give it to them now, they won't listen to the rest of the stuff. No. Okay, time's up, everyone. Pens down. You too, pen down. How did you go? And I'd be interested to see how many related words people came up with there. So let us know in the chat how you went and what did you learn by engaging in that task? What did you learn about teaching vocabulary in science? And maybe what did you learn about what you have to go home and research? Now, I know everyone wants the answers to that quiz. Oh, quiz, there we go. And the good news is I do have the answers, but the bad news is you have to wait until after the webinar to receive them. So when we send out these slides, I'll send out the answers to that, because we all know if I give you the answers now, you're going to be ticking off your little correction, see how many you got correct. You're not going to listen to the rest of the webinar. So good teaching, everyone has to wait. No Googling. I should have said that at the start, no Googling. I just trusted that you wouldn't use Google to get those responses. Now I see Miss Fairley in the comments, you've said, reflecting on the video from the lesson, talking about the empowering part of teaching students how, so it doesn't matter, you're right, it doesn't matter about whether students actually remember the osteoporosis, but it's that idea of helping them to learn how to look inside the word that's the critical part. The other thing I see, I think it was Julie was talking about, it was great to see them chunking the words. I forgot to point out that when we're breaking these words apart in science, our students are used to breaking words apart by syllable. So if you think of a word like unhygienic, we would usually clap it out and break it up by syllable. This is different to breaking it up by syllable. We're actually breaking it up by word parts, so which may or may not align with the syllables. Does that make sense? So we're breaking it up by morphemes. So the smallest meaning of smallest unit of meaning in the word. And our students will be so used to breaking it up with syllables that they sometimes will miss that it actually has a word part that it can be broken up into. Okay, so just to finish off on the vocab part, in the Literacy Teaching Toolkit, it says about teaching base words and word parts, it says, rather than memorizing words, students can learn about morphemes as a way to look inside unfamiliar technical terms to find the meaningful parts, and that's what we've been focusing on. Understanding how scientific terminology is structured using common Greek and Latin morphemes and how morphemes connect words in meaningful ways offers students portable knowledge. So portable, port, this is a little, if you're ever in a quiz show, port means to carry. So when we're talking about portable knowledge, we're talking about knowledge that they can carry around with them and apply to other areas. So if we know what ology means, we can carry that knowledge around with us and apply it anytime we see a word with ology on the end of it. And that's what we've been, as Miss Fairley alluded to in her chat comment, it's really about building the skills of the students to do this more so than them actually walking away saying, well, I know exactly what osteoporosis means. So we're giving them strategies that they can apply in other circumstances. The final point I wanted to make about vocabulary instruction is this idea of tiers of vocabulary. Now, this is on the Literacy Teaching Toolkit. The idea that Beck and McCown suggested there are 3 tiers of vocabulary. The first, tier 1, these are everyday words. And I liken these to words that our students are going to come across in everyday speech. What are they going to be hearing when they're out? I was going to say running around, but in the high school environment, you don't see a whole lot of running around. When they're sitting around at lunchtime with their mates, what's the vocabulary they're going to be hearing? So that's sort of the tier 1 stuff, word, number, table, some examples on the right. The tier 2 vocabulary is more the academic vocabulary. This is more the vocabulary that they'll be exposed to usually in literature, school-related or education-related literature. So we're talking, if you can see on the right there, words like analysis, argument, justify. So they're not necessarily words that they're going to be hearing at lunchtime when they're talking with their mates. This is the world, or really the vocabulary of academia. We're talking about that tier 2 language. And tier 3 is that technical vocab. And so in science, obviously, there's so much technical vocab. So we've got some electromagnetism, a couple of morphemes in there, chlorine and photovoltaic. This is the technical vocabulary. So it's not as portable. It's usually specific to a content area, whereas the tier 2 is generally quite portable. We can use that across different content areas. So they're suggesting that within science, explicitly teaching tier 2 and tier 3 words will allow students to access and communicate scientific content knowledge. So we're not always focusing on tier 3. We need to build in those tier 2. You know, when you're on an essay and we say to the students, analyse this, and then we think, oh, why didn't they do that? Have we built their knowledge around what analyse means? What are we looking for when we say the word analyse? Okay? So there's more information about this on the Literacy Teaching Toolkit, that idea of 3 tiers of language, to help us really in science to work out which words do I need to spend explicit teaching time on. And some words are better than others for teaching. Some words can crack open access to a whole bunch of other words. So we've got to be a bit choosy about which words we use for our explicit instruction. Okay. I will give you the 2 minutes to reflect on the learning and the discussion that we've had around vocabulary. So I want you to think about what do you agree with, what is new, and what questions do you have around vocabulary instruction in the science classroom. And I'm going to give you 2 minutes to do that. I'm just going to skip over the reading part. I'm just going to tell them that you've got it. Okay. I think it's more important to get to the resources and tell them about next time. So actually, it sounds like a lot of them are actually English teachers.
There's a couple of English teachers, a couple of literacy leader specialists.
Right.
But there's a lot of science teachers.
Oh, okay.
But it might be about telling their colleagues.
Okay, I do understand that 2 minutes is too short, but I do like to just give you a very quick amount of time just to think about what does that mean. And of course, you will go home tonight and think for the rest of the night, what does this mean? What are the implications for us as teachers of science, or for us as literacy leaders building the capacity of science teachers to teach the literacy of science? So apologies for the 2 minutes. Now, I'm not going to go into I want to talk about reading in the science classroom. I'm just going to make a couple of points about, and I've left you with a resource to engage in by yourself. First, this is a slide with far too much text. The point, I put this in here because when you get the slides, I want you to have access to the whole entire paragraph. The point I want you to take away from this thinking about reading in science, in the rush to ensure that students experience what it means to engage in scientific activity, teachers often discount the fact that science is indeed a largely literate activity. Scientists spend most of their time reading and writing, and the whole rest of that paragraph gives examples of how they read and write. So I think this is something that we really have to build that understanding of the science teachers in our schools to believe and to understand this, and what does this mean for how we teach the literacy in science. What I would suggest that you do, I've provided you with a reading. This is from the Shanahan book on adolescent literacy. This reading is about a group of scientists who get together and actually think about, well, how do I read a text? So when I'm presented with a scientific report, do I read it from top to bottom? Do I read a little bit, go over to the diagram, come back? Do I just read all the subheadings first and then go back to the top? What are my processes? Because that is what we want to be explicit with our students. So how do scientists read? So I suggest that afterwards, when you've reading this, think about these questions. What strategies do they use? What do you use when you're reading a scientific text? How do scientists approach texts? So after this, and you can share this with your colleagues, read the excerpt from this text and then consider what are the implications for us teaching the literacy in science. And I would even encourage you to replicate this activity. I would encourage you to read a scientific text together and then have a discussion to say, what did you do? How did you read it? What did you look at first? What didn't you look at maybe? So because they're the little keys and the clues that we want our students to be learning about. So that text is a part of the supporting resources pack. Okay, these are the questions that you need to be asking when you're reading that text. What's going on inside my head? So we're talking about metacognition here, being aware of our thinking. What's going on inside my head when I'm reading this text? How did I select what to read first? And when did I use the graphics? Did I use them first? Did I use them as I was reading? Did I wait until I got to the bottom and then I went over to the graphics? That type of thing. Okay. All right. The final resource that I want to talk about from the Literacy Teaching Toolkit, this is what I was talking about, how they have on there's access to a text and they've shown how to pull that text apart and what the different elements of the text are. So perhaps if you're an English teacher, you might be familiar with this process of pulling a text apart and talking to students about it explicitly. For science teachers, this might be new to you, but this is something that can help our students to access these texts because we do read scientific texts differently to some of the texts that we're being exposed to in the English classroom. So we've got to give our kids clues about how best to do that. So that is available on the Literacy Teaching Toolkit as well. Final section, resources. Always leave people with books because I love buying books and I think everyone else needs an excuse to buy books. These are 3 of the books that you would look at if you want to increase your knowledge around vocabulary in the science classroom and explicit vocabulary instruction. These are the 3 books that you would look at. And you'll get a copy of the slide. So I'll move on. Disciplinary literacy in general, if you're maybe a literacy coordinator or a literacy support person in your school, these are some of the resources that I recommend for you to help build the content knowledge around for each of the different disciplines. This is disciplinary literacy. That gives you an overview of each of the disciplines. The one on the far right, adolescent literacy in the academic disciplines, I found this one really useful, and that's where your reading has come from. So there's some supporting resources. Let's go back to our understanding goals. Goodness me, doesn't it feel like a long time ago that we saw these? So you'll understand the importance of explicit teaching of disciplinary literacy in the science classroom. I hope I've convinced you that science teachers and all teachers of disciplines need to teach the literacy of their discipline. And we can't leave that up to the English teacher because they're teaching the literacy of their discipline. You will develop knowledge of a range of effective disciplinary literacy related teaching practices, and we've looked at a couple of different things, so the vocab, the part card strategy, that type of thing, and deepen your knowledge of the supporting resources. Before I finish up, just for your information, March 4, we're going to look at the Literacy Teaching Toolkit English. So that's on March 4. And on March 17, the Literacy Teaching Toolkit for Mathematics teachers. So jot those dates down and get onto the Basto website to sign up for those webinars. That is it from me for tonight. You will receive a copy of all of the slides, and yes, I'll send out the answers to the generative morphology as well. And don't forget to keep a link to the Padlet. In the Padlet, there is a Survey Monkey. We want to get your feedback about what resources and assistance do you need to be able to talk about Literacy Teaching Toolkit in your schools, and how can we make our webinars more interesting, or are they meeting your needs? Let us know. So there's a link in the back channel for that. So thanks very much, everyone. It was lovely to have you with us. And I might see you again at the next one, at the English one, if you're really keen on finding out about the English version. Good night, everyone.